All right, let's get started. Thank you so much for joining our online seminar. Today, we're going to have like online seminar number 38, Why Excel Users Love Exploratory, and part 2. And before going, let me introduce myself. My name is Kan Nishida, CEO at Exploratory. Um, we started Exploratory almost like 4 years ago, back in 2016 spring, to democratize data science. Prior to starting Exploratory, I used to be working at Oracle for about like 20 years or so. As a product development director, leading the team, building the data science related products such as visualization tool, BI tool, or machine learning tool, and so on. So I've always been involved in the data or data science. Especially for like a building product and stuff. And then towards later, time at the Oracle, I started seeing a lot more innovation and new technology and algorithms started coming out, not from those corporations, but rather be coming from the open source. So I started thinking, like how we can build a gap between the world of programming or open source and the rest of the folks, like most of us. So that's sort of like the starting point. We wanted to bring the cutting edge or modern technology and innovation in the data science into everybody's hands by building the simple and UI experience product. Okay, and our vision is everyone will be making informed decisions based on data. I said will be, but obviously many folks already started doing it, right? Because the data is more available. So I think it's really important and critical to democratize this thing called data science. Today it's more like kind of mysterious, but I want to make sure that one day we don't even have the word called data science, so that everybody actually doing it, sort of like as a daily thing. When we say data science, we usually always starts with the questions or business problems, and then like you want to use the data to solve the problems or answer the questions. And when you access the data is most of the time like not ready. So like you want to clean the data or transform the way you can visualize or analyze. So that's called data wrangling. And then you want to use charts to visualize so that your eyes can find the patterns and the trend in the data. Sometimes that works, but sometimes not, because our eyes have a limited capability recognizing the signal from the data. That's where you want to use analytics, such as statistical algorithms or machine learning algorithms, to find the patterns and the trends that our eyes cannot see. And then you go back and forth this process until you find insights that help you answer the questions or solve the problems. Then you want to communicate that insights with others so that not only you, but also your team or your customer partners all can make the better decisions together. So these 5 steps, we think those are necessary or essential for any data science project. And the Exploratory provides the single and a modern and a simple UI to do these 5 things in a very cohesive manner. Okay, so enough about Exploratory. So let's get started. Exploratory online seminar number 38, Why Excel Users Love Exploratory, part 2. So we interview or we talk to our customers often, and then we keep hearing this kind of patterns. And many of our users used to be using Excel or still using Excel, but switch completely to the Exploratory or switch some of the works to Exploratory. And then they tell us, we based on our interview, like we find some patterns, and then these are the 9 things that we often hear from our customers or users, like why they transition to Exploratory or why they use Exploratory over Excel. Okay, so then the first from number 1 to number 5, we already done that last week as a part 1. And there is a recording available. So you want to go to our website, and then there's a Learn menu. Under the Learn, and then there's an online seminar. And the online seminar page, when you scroll down to the bottom, and there's a link to the past seminar. And then there is an online seminar number 37. That's the part one. Okay, so today is a part two, starting from number 6 to number 7. So these are the 4 topics I like to cover today. Okay, so let's get started. Number 6. So without number 6, the intuitive understanding with visualization. And this intuitiveness is very important. Sometimes people underestimate. But without the intuitive understanding of the data, then we fail to realize the problems with your data. They're not sure what you get is what you have expected. This is especially around like data wrangling. And then fail to find the patterns in your data. The patterns are there, but how you recognize, and some people can recognize, some people not. And it's so sad that if you can't recognize, even though when there is patterns. So these are the things that I like to talk about. And let's start with the first one. So typical problems, there are tons of problems with the data, right? But these are 3 typical, very common problems. Number 1, missing values. Number 2, outliers. And then number 3, the not sufficient data. So when you have the data in Excel, and it looks like text data, right? So looks okay, but basically the problem is like what you see is basically only in the window, and then you want to see like if there's any data problems or not, then you want to start scrolling down and up, and then there might be missing values, but you won't notice unless you scroll enough down to the particular spots or something like that. Or there might be outlier values, and they happen to be like this is a sales data, and then maybe like a sales number is super big because of special customer or special country or something, or somebody type in as a special values in place of an A or missing value or something like that. So this can happen, and it's problematic when you want to understand or visualize or analyze the data. And again, this is hard to recognize. I highlighted in the red color, but typically like there is no color format, so hard to find them. And then here's the insufficient data. So let's say like you are expecting, for example, December data, and then December 1st to December 31st, but then when you scroll down, like you notice, oh, December 20, and then looks like there's no data after that. Now, obviously, like you want to see, like, okay, you want to assume maybe the new data might be coming or something wrong with this data. But unless you scroll down and then see data, and then, of course, this data is sorted, but if it's not sorted, then there's another problem. So these are the typical problems that like when you get the data you have, and then if you fail to recognize these problems, and that's fine. Sometimes like you go on and then like you start analyzing or transforming that data and stuff. But then at the end, let's say that you get the top 100 customers, based on the sales or something like that, then you don't want to pass this data, because if you do, you're not sure like this really the top 100 or not, if the original data had an A or outlier values or something like that. So then like you think like, hey, this is something weird, and then okay, so now like I have to go back, right? So okay, so there's something that outlier value I need to modify or adjust, which means you have to go back to the original and then make sure all the downstream data, so cleaning or adjusting or transforming steps are accommodating those changes appropriately. So you have to go one by one. And that's just a nightmare. So with Exploratory, you can import the data. I'm going to just quickly switch to the demo from here. So like I have the similar data, grow like this sales data. So like I'm gonna use this one. So click on it, and then I'm gonna import the Excel data. I created sample data for today's session. So here's a sales data. I'm gonna just double click, and then it looks okay, and then like I'm gonna just save it. So looks, when I say looks okay, like I mean like looks okay at the first maybe like 150 rows or whatever the rows, but I'm gonna just click on save and then see if this data looks really okay or not. And then the first thing I see is a summary view. If you're Exploratory user, this is nothing special, but that summary view. And then like I can immediately see, for example, postal code has, or more than half of that data is like an NA. And then when I scroll down, like for example, sales, okay, so there looks like there's 13 rows is NA, and that is 0.03%. It's probably marginal, but there are some NA values. And I can see like some of the others columns also contain NA or missing values. And not only that, like when I see here in this like a histogram, and most of the data are in this range. Like there's a total in 51,000 rows, but then uh, 50,000 rows or 50,700 rows were in this bar. And then there are a few, so for example, something like this, there's only one row, it's in this like, greater than 20,000, $20,000. This is US dollars. So these we consider as outlier, and we want to make sure this is actually reflecting, like expected. I mean, like what we expect, or maybe something wrong with that. Maybe the different currency unit or something. So maybe that's not a problem, but like at the least we want to make sure with the one who create the data or manage the data, right? So these are the things that you can quickly recognize the problems. Another thing is here. Here's a date data. So POSIX CT and a date. Those are the two data types for date and time data. POSIX CD contains a time element, time component, where date data type doesn't have the time. And in this POSIX CD, the last CT is like calendar time, stands for calendar time. So like that's why like you can kind of recognize, oh, this is something to do with time. But anyway, you can quickly see the time period. So 2012, in this case, January 1st to 2018, December 31st. So you know that what the period of this data. And if you, this is a kind of old data, but if you know the end of this period is the end that you expected, then that's fine. But if it's not, ending at that point like you expected, then you might want to go back to to the person who is managing this data, or you might have some problem in the data generation or data extraction piece. Okay, so this is a summary view. Well, recognizing that problems with that summary view. Okay, so next one is, I think I skipped a couple things. Here. Next problem, not sure what you get is what you have expected. And this is especially around data wrangling. And the data wrangling is about transforming or cleaning the data step by step. And you want to make sure whatever you did actually caused made a change that like the way that you expected. What I mean by that, for example, let's say like we want to join two data sets. One data set, like order data or sales data, and then that sales data is aggregated by the country. So each country has a sales amount, right? And then, but we don't want to compare the sales amount by itself. Like we want to actually bring the population so that we can actually calculate sales per population. Then it's easier to compare, among the countries, which country is performing well, not performing well, that kind of stuff. And then in the Excel, you can use VLOOKUP function, and then you can fill that population column, right? And then once you do, and then looks okay. So maybe like you can start, transforming the data. You can start like ranking and comparing the creating charts and all the stuff. But if you're careful enough, then you scroll down, then you find the NA for the population. And it turned out when you look at the country column, it says US. And this happens a lot because the US can be United States or that United States or USA, and who knows. And so that means you want to make sure this original data set, sales data, and then the population data set has the same word representing the United States. And in this case, that's not the case. That's why like you don't get the population value for the US row. Okay, so with exploratory, obviously you're going to use the UI. I'm going to quickly do that demo here as well. So for this, I have this like a sales by country data. So this is like 185 countries, and each country has a sales value. And I want to bring the population data for each country. Country name is right here. And then the population data is here. This is like a country and also population. So let's say like like the same thing. Like I'm gonna join this with the population data, and I'm gonna select the join, and the target data frame, and then let's select the population, and the country column, and the country column, and it looks okay, and I'm gonna just click run button, and then I get that population. And if I'm looking at the first sort of like 30 rows or so, like it looks okay, but always I can go to the summary view, quickly check that the result looks okay or not. And here, like when I see the population column, it says NA is one row and 0.54%. And what this means, so like I can go to, for example, quickly on a table view and use this table filter. This filter applies only for this view, not as a step. So it's kind of convenient to, debug or like see like what's going on in that particular this table view. But here, what I wanted to do is population is NA, right? So like keep only NA and then click on run button. So this is the row out of 185 rows that has NA for population column. And it turned out the same, like we know it by the slide, but here's a country, the US. Okay, so here's a problem. So I'm gonna just get rid of this table view filter. And then what I want to do is I want to convert that US to that United States. So let's go to this country population here. I think this one also, let me see. Country is contains contain and United and ignore case. And here you go, United States. So population data has the United States as the United States. So I want to convert that US to United States. There are a couple ways to do it. Let me go back to the original data. Literally, you can rename it US, United States. And you can actually do it by replace values with new values. Then you can create that mapping. Another way I actually like to do it is here under the work with text data, the convert, and then underneath there is a country, this is like a world country. And then when I click on it, I get this convert text UI. And here, there's a country which is already selected. And from country name to, for example, like ISO code, like ISO 2 meaning US, ISO 3 meaning like USA or something like that. But also here, just country name is fine. Like I'm gonna just do it here. And what that means, if I query US, US becomes the United States. So this is kind of weird way of using this because you're converting from country name to country name. But this function can standardize a name. So even like if the original data was US or that United States or USA or any type of the name, but always return as a United country, the kind of a standard country name. So that's I prefer to do it. Another more precisely sort of like a right way to do it is always convert to ISO 2 or ISO 3. Then even like the other one, the target data frame, you want to convert to ISO 2 or ISO 3. Then you always kind of know like the ISO 2 and ISO 2 can be joined together. A perfect matching. But here, I'm going to just use this one country name, and then convert it. But look here, I actually did at the step after the left join. And then that doesn't make any sense because it's already too late, right? So like I should have done this conversion before doing the joining. So I can actually move this step and drag and drop, and then drop it right before the left join. That means by the time we do the join, the US, you remember that row, has already become United States. So let's see like if that's the case. I'm going to click on this left join, the number 3 step, and then go back to the summary view. And here it is, the population column now doesn't have any NA. So that means they're joined together, nicely. Okay, so that is the power of sort of like intuitively understanding your data at every step when you do the data wrangling. Then like you can, if there is a problem, you can fix it right away. Okay, so another thing is, so let's move to the next one. The fail without intuitive understanding of data, fail to find you've tend to fail to find the patterns in your data. So what that means? This is something to do more visualization, right? So when you look at data like this or chart like this, and this is actually the y-axis, the return rate. So like when you sell something and some customers, percent of the customers always return something. So like what's the percentage of that? And then like I just visualize on the time scale, time series. Okay, and there is some kind of spike every so often. And when you look closely, this is actually along like a December time frame. Then from here, you can change the way to visualize. Then you can see, okay, this is actually the December. December has a kind of a special sort of like a patterns going on, or the seasonal trend is can be seen. And then, but in Excel, creating a chart is sort of like a hustle. And that itself, you have to summarize the data first. Then you assign the column to the chart, and then you get the visual. You get the chart, and then and then, like, if you want to start doing something more, then or change the assign column or something, and then you have to go through this kind of intimidating UI dialog. And if you want to switch the chart type, and then each chart type has a slightly different way of configuring the column, assigning the columns or configuring things, so you get kind of confused. And I talked about this in the last part 1 session. Is like a learning cost in Excel is actually not that low. It's actually quite high, especially when it comes to data visualization side. So that means you end up like not really exploring the data or not really discovering the pattern because of that. Then you have lost the opportunity for recognizing some patterns, which is the most important thing in a data analysis. With exploratory case, let's do how we can quickly find those patterns. So if I go to which chart I'm going to use? Okay, let's go back to the sales data, and then go to the chart, and then let's visualize by using the line chart and order date. And then I'm going to assign a y-axis to this return. This return is actually interesting because this is a logical data type. What logical data type is that basically it has only true or false, and that's a special data type. And then when under the chart, I can assign it. And then right after I assign, like the default is the number of true, basically counting all those true. But I want to see the percent of true, then this becomes a return rate. Okay. And then that looks good. And then, but now like I'm basically aggregating by the year, right? So here, like around year, that means like January, all the January dates become the January 1st, 2012 January 1st, and then all the February also become the January. And then do that for every year. But I want to see by the month level, something like this. Okay. So each data point is now representing the day, the months of each year. And then these are the spike that I was talking about. Looks like December has a spike for the return rate, and it looks like people return things in the December. And then like if I actually want to see like if that's a December, like how the December is so special, I can actually instead of doing that round, I can use the extract. So let's say like I want to extract just a month. That means get rid of the year information. The x-axis, all I'm seeing is January. This January can contain 2012, 2013, 2015, and all those years. But I want to just focus on the month level things because I want to find like monthly or yearly seasonality, right? And then like, I can assign the same column, like order date. And then this is already good because this is like a yearly rounded. So like this 2012 January 1st, 2013 January 1st. Or I can extract. Basically, this is going to be the same thing. Just only the difference is just the year here, or it comes with like a 0101 kind of thing. But by looking at this, so x-axis is the month, and then the color or the group is now the year, then I can clearly see that December is something special, really weird thing going on. And then it's not like increasing, maybe slightly increasing actually, but the percentage wise, so that's troublesome. But in overall, the December return rate is especially huge. And then here, so in the exploratory chart, like this always any chart you create, it's all like for example, even like in the bar chart, x-axis, y-axis, and the color, that's the same thing in terms of the configuring the chart. Not just a bar chart or line chart, but also even like a scatter on other charts as well. And so it's easy to switch between the charts, and then you don't have to relearn how to configure the different charts kind of stuff. And also this repeat by also for every pretty much most of the charts. So you can use this to separate this chart into multiple groups. For example, I want to actually create one chart for market. And I'm going to just configure the way it's shown, maybe like a 3 columns. Okay, that looks good. And then the here, what we are looking at here is the return rate trend by monthly for each market. And then look at here, the USCA is the United States and Canada. So that means North America. So North America's return rate is significantly going super high in December. And it turned out other areas are not. Maybe like I might see like Africa a little bit here, and so, but it's not much. So basically, the thing like we thought like December is like a super high, has a super high return rate, is coming from the United States, Canada. So this kind of information is very useful. And then this can be possible if you can quickly create the charts and then explore the data quickly. Okay. So that's the part. So being able to understand the data intuitively and visually, I mean, intuitive and visually comes hands in hands, basically kind of same thing, but it's very critical in any steps of data analysis. When you import the data, it's important because you want to find the problems right away, or you want to see like how the data is. And then when you do the data wrangling, you want to make sure like by using summary view or even the chart to quickly see what you get is what you have expected. And the data visualization, being able to quickly explore the data and then discover the pattern itself. Now that you're already getting some useful insights from that data. Okay, so next one is the 9 reasons why Excel users love Exploratory. The number 7 is better and quicker analytical capability. And Excel is, I hate to say this, but Excel is not designed for analytics, even though many people in the world actually does it. So, like I'm not saying like you cannot do it, but it's just not designed to do it. But hey, I mean, like Wall Street, I mean, the financial people are doing it. Yes, they're doing it, but most of you won't do it because it's hard to do it. So the point here is that can do doesn't mean will do or even like want to do. Um, So for example, so let's look at the correlation, right? Like what the correlation? Correlation is when you have the two variables and one variable's change tend to happen along with another variable to change. So in this case, for example, age and monthly income, and then like an older you get, and then bigger or higher the income you get, right? So seems like this orange dot represent one person for one employee, for example. Then you can see like, well, these two variables are correlated. And the correlation means, there's something called correlation coefficient. You can calculate the strengths of the correlation. And typically you represent the, as a number, and it's ranging from -1 to 1. 1 is the highest, the strongest positive correlation, and then the other side, -1, is the strongest negative correlation. Negative correlation meaning the one variable increase and the other variable decrease, and going opposite way. But it's basically positive and negative, but if there's a correlation, that means there's some kind of relationship between them, right? But then zero at the center here that means no correlation. So it doesn't matter, like for example, age and income case, it doesn't matter like how old you are because the income doesn't change based on your age or something like that. Okay, so in Excel, yes, of course, you can calculate this correlation coefficient by using correl function. And then you get this number, let's say like 0.8143 something something. And then you say, oh, okay, looks like there's some kind of correlation here. And that's mostly true, but what does 81 mean, 0.81 means? And it turned out there's this something called Anscombe's quartet. This person figured it out, found out, even with the same exact correlation coefficient number, the data can look very different. So whenever like you calculate this correlation coefficient, it's actually good to know because you can use that to sort of like prioritize where to look or compare among other variables. But you always want to make sure to visualize it so that you can understand what this number really means. Right. And then in Excel, yes, you can create this type of scatter chart. I mean, the best way to do it to visualize the scatter chart. But yeah, it's again, like I don't want to keep talking down about Excel. I mean, like you can do it once you get used to it, but it's a little hard to do it. And then also another thing is not just two variables. I mean, there are bunch of variables, and then you want to see like which combination has higher correlation. Then you have to try like every single combination. So that's cumbersome. So with exploratory, let's see like what you can do. Like three steps. Number one is visualizing it. Number two, calculating correlation coefficient for every single value. Number three is it becomes more analytical. So let's see. So here, this is the same data, the sales order data, and I want to see here is like a sales, and then like if maybe like what are the correlated between the sales and the discount or marketing or sales comp. Meaning, if you do this is marketing spend, so like if you spend more on the marketing, then maybe sales increase, or this is sales compensation, which means like you give carrots to the sales representative for increasing the sales. So does that mean like if we give more bonus to the sales folks, then like we get higher sales, right? So that's the kind of thing. So like you can go to the chart view and then use a sales as scatter chart, and then like I'm gonna assign like a sales comp, and then y-axis I'm gonna assign a sales, and I want to see like this relationship. And it turned out these are the one like I was talking about, like outlier. Looks like there's one order is this huge sales amount, but like there's not much. Most of the data is around here. So if you have these outliers, and then like you say, hey, there's a correlation, tend to be the correlation value or coefficient tend to get kind of give you the confused values. So what you want to do is like, hey, what if like if we ignore this? This might just very exceptional case. And then let's focus on sort of like most of the data so that you can see the general trend. Then you can actually check this box off and then to exclude the outliers. And then now, like we are looking at the sales ranging from $0 to $600, sales comp $0 to $60 range. And then looks like there's some sort of like a relationship or something. And then here, like y-axis, there's a trend line. By drawing this trend line, you can actually see this like a linear regression line, which basically try to draw the line in the middle, making sure the line and all the dots, the distance between all the dots and the line to be minimum. So it's basically going to base kind of a center area, middle area. And from here, you can see like a correlation 0.78. So that's the correlation coefficient. So it's, positive and a relatively strong correlation. But this is what this in this particular scenario, 0.78 or 0.79 mean. Okay, and we now know the sales and sales comp and sales has some sort of relationship. And how about others? Maybe like marketing. How about the discount? And how about other variables? And that you can actually use this chart and go click switching the columns for the x-axis and y-axis, but that's going to be kind of cumbersome. So you have a way to calculate correlation coefficient or every single numerical variable. So here under the analytics view, and then go to the correlation, and then I'm going to select all the numerical variable. And then also you can select logical as well. Text you cannot unless you convert that text column to numeric by doing something called one-hot encoding or something like that. But otherwise, this correlation is for numerical variables plus logical. Okay, so now here I'm going to click OK and then click Run button. And then this will give us that this heat map that visualizes that correlation coefficient. So the higher is a darker red and the lower, or like if it's a negative, then the blue color. So from here, looks like a sales and sales comp 0.77. And then here, another one, the sales and marketing, also 0.75. So it seems like these two, combinations they have higher correlation, positive correlation. So this is pretty cool. You can quickly try out, and then I can go to the scatter matrix. Then you can see what type of relationship. Again, this view includes the outlier. So if you want to exclude outlier, you want to create a new step to exclude by using a filter step to exclude the outlier. Then you can actually try this one as well. But another one, when it comes to correlation, another one is really important. Interesting is here. If you know what you're interested in this case, for example, you're curious how the sales change or like increase or decrease, then you can use this correlate mode. So clicking on this correlate, and now you are in the correlate mode as long as you see this green bar. And then you can select the variable name, in this case, the sales. Then basically this gives you the relationship, not only the relationship, but also the correlation value, or R square in this case is actually the square of correlation coefficient. Then you can see like which variables are more correlated to the sales. And then you can actually sort it by, let's say, like R squared or correlation, either way. And then like you can see like sales comp, marketing, subcategory, these are have relatively higher correlation. Okay. So that's something that you can quickly do by just clicking the buttons. And another thing, though, is one thing you want to be careful is coordination is not causation. And this is almost like a cliche. You hear this all the time. So there's something that maybe I don't really have to go into, but let me just, for example, something like this: ice cream sold and shark attacks, and then turned out both of them go increase as the months goes by, and then but that doesn't so shark attack ice cream sales and seems like a correlated. So therefore, like if you increase the sales of the ice cream, then we're gonna have like more shark attack. Or if you invite more shark into our ocean or bay, then we can expect more ice cream sales. And then, we know like that's not going to happen. And then also this one, it turned out, is a temperature, is a something called confounding. But that's actually the one that is actually making ice cream sales increase. I mean, like the hotter temperature, warmer temperature, then more people want to buy the ice cream. And warmer temperature, the more people want to go into the ocean, into the water, and then the shark wants gets that much increase the chance for encountering for the people to show people on the shark. So these are the things that we have to be careful when we start seeing the correlation. So that's where like you want to use a multivariate analysis. So I'm not going to go into the too much detail. If you're interested in, like I have done an EDA, exploratory data analysis seminar a few weeks ago. So you might want to go check the past recording. But anyway, if you do the multivariate from here, let's say like, hey, sales comp and marketing subcategory, which one is really the one that have something to do with sales? Maybe sales comp and marketing are itself, these two are correlated. And therefore, because sales goes up and then marketing goes up, and then that's why like sales and marketing seems to have some relationship, but it's actually coming from sales comp or something. So in that case, you can select, whatever the variables. I selected 3 this time, and then from the column header menu, to create the linear regression model. And then this will basically, this is a or multi regression. And then here, I can see the relationship between the sales comp and the sales, and the marketing and sales, and the subcategory and sales, when assuming other variables are constant. So for example, here the sales comp, and then when this relationship, this blue line relationship is assuming that marketing and subcategory doesn't change or as a constant value. Okay, so and then also by going to the importance tab, and then we can see which variables are more important in order to predict the change in the sales. So it's, in this case, sales comp, marketing, both of them actually have some relationship, strong relationship with sales as compared to other variables like subcategory. Okay, so that's the quick way of doing the analytics. And again, you can do something like this in Excel, but will you? That's the question. Okay, so can do is not equal to will do, and so it's much easier to do in exploratory. Okay, so the next topic is reproducibility for reporting. And I think this is actually the very, I hear this often, that this problem is Excel. When you have to create a report, typically like, you present in a spread, let's say, PowerPoint or something, then you create a bunch of charts in Excel. Like, I've seen like a crazy Excel, like tons of charts in the Excel. But anyway, so you do that. And then after that, like you copy and paste, right? And then like you create a nicely format slides. But the problem is, you need to copy the charts one by one. And if any problem is there, like you needed to do this again. And then the charts pasted in the report are not guaranteed to reproduce the same result that you expect. So this whole copying process, and I don't even have to go keep talking about this, right? So if you have done like Excel, like you know what I'm talking about. So I just want to quickly jump on to how you would do, like what's the difference in exploratory. So in exploratory, once you create those charts, per each data frame, then you want to create, you can create dashboard, note, slides, and so on. Let's assume that you created a node to create a report. Then you can directly embed the chart. You can do the image as well, but you can directly import the charts. Then if you added the comments to the charts, original charts, then those comments will be copied along with the chart as well. Okay. And then if any problem with data, what in the Excel case, no, sorry, like exploratory case, let's say, this happens sometimes, like original data in Excel was something wrong. So somebody gave you the updated data. Then all you need to do is just go to the local data step and then swap with the new data or re-import that data. Then all the data wrangling will be done automatically. Or maybe like step 2 or 3, you found some problems and then you fix it. And then any downstream data wrangling steps will be processed automatically to accommodate any changes at the upstream. So you don't have to go through like every single step and then adjust anything like that. And then the charts, bunch of charts reference into different steps. And then those charts also will be updated automatically. So you don't have to reconfigure the charts or refresh the chart or anything like that. And then most importantly, if you have a note, you don't even have to go, visit every single chart or anything like that. All you need to do is just like open the note and click on this run button. And this will generate all the charts at the latest, with the latest data to accommodate any changes you made in a data wrangling step or at the source level. And you don't even have to go to the data frame to refresh the data. If you have updated that same data in Excel, let's say like somebody could change the data or something like that, then all you need to do is actually click on this re-import data button. And this will re-import the data and then run all the data wrangling steps that are required to generate whatever the charts you have embedded in the node. Then you don't have to go through, you don't even have to open the original data frame at all. Okay, then the chart pasted in the report are not guaranteed to reproduce. This happens a lot when you receive the chart Excel, and then you want to customize, and then some of the charts are not working, or you want to customize, but you have no idea what is actually really going. So all you need to do, you want to change that from the country level to maybe like region level, and it becomes a nightmare. And that's because Excel by nature, it's whatever you do in Excel is kind of like a black box. Unless like you are the person who does it, who created it, like you have no idea what is in there, in not just the data wrangling side, but also even the chart creation process as well. And then like you don't know, like, for example, like you have the PowerPoint, for example, or Word document, and then because someone copy and paste, so there are multiple versions of the charts in Excel, and you have no idea which chart is coming from which sheet or which version of the charts. So with exploratory case, when you share the report, you can share by publishing or you can share as an EDF. And then that means you receive the EDF and you import that EDF into your exploratory environment that will reproduce to whatever you see in the report. So what that means, I'm going to actually do this one quickly. The EDF, by the way, it stands for exploratory data format. That is a data reproducible format. So here, I'm going to click on this report I've created before the seminar. And the left-hand side is I already imported the chart. And then in order to import, by the way, click on this chart button and then find the chart. And then all you need to do is just click on OK button. And then this will copy and paste this sort of like a reference tag. Okay, so I have this chart, report with a bunch of different charts. And then I can export this one as an EDF, exported data format. And I'm going to just export it here. And then what has just exported is not just this node, but also all the data frames and the chart information that are needed to reproduce this node. So what that means, if I go to, usually I give this to someone else, but pretend I just, I am that different person being shared, then like I open the project, and then like here, I'm gonna click on plus button, and it says import EDF. And then I'm gonna select this global sales EDF and click on open button. And this will open not only the import, not only this node, but also notice here, I have two data frames. Those are the two data frames required to reproduce this node. And when I click on run button, and then basically now it's try to reproduce those charts. That means might have to run some of the data wrangling steps, and then I get these charts. And that means I can actually go back to each data frame and see how the chart's being generated. So for example, here I see exact the same chart that I saw in the another project. And then like a right hand side are all the data steps that we are required to produce some of the charts here. Okay, so that's the reproducible reporting, and which is we think it's very important. Okay, so the last thing is a ninth reason. Easy to share, but in a managed way. So easy to share is important. So we share as an EDF in the previous step, but typically what happens is people send an email, right, with Excel file. And this will create multiple versions of Excel within the organization. And not just email, I mean Slack or maybe the Dropbox, and there's tons of different versions of the spreadsheet. And then nobody knows which one is the right ones to look at, right? So this we hear a lot. And so the problem is we call this like a data governance like problem. So not sure which data file is the correct one, not clear what is in the data. Nobody knows how the data has been transformed or manipulated, or someone has to keep updating the data manually every time like the new data comes in, and then like the email and the Slack becomes going crazy. But with Exploratory, you can publish the data by clicking the button. And then once you publish, you can share with certain folks by inviting them, or you can enable the URL so that like anybody knows that URL can open. And then once you do it, this is our server, the cloud server, exploratory.io, or you can install the exact same thing on your on-premise server called collaboration server, either way. And then you can open the data in the web browser in the summary view or table view. The table view, you can search whatever the particular rows you're looking for. And then also it has a metadata tab that shows you the data dictionary information and the detailed information about that data. And then you can schedule it. And this schedule doesn't apply if you're dealing with a locally saved Excel file, because Exploratory server cannot access to your local file system. But imagine like your files are at a remotely accessible place, like maybe some Google Drive or Dropbox or S3 or whatever. Then you can schedule. Or you're getting the data from a database, then database also in AWS, and it can be accessible from outside. Then you can schedule to automatically update the data. Let's say like every 6 o'clock in the morning or something. Then once you upload that data though, then you can download. I mean, not only you, of course, but other folks you share with can download the data as a CSV. So everyone think this is a source of truth, and then start from here and then do their own thing, even like with Excel. Or if you have some system, then you can use the API, REST API, to download this data either manually or automatically. And of course, this data also can be imported or exported as EDF, exported data format. So last one, like I showed, that was for note, but this can be for data, or can be chart, can be dashboard, anything. And by downloading this EDF, then you can reproduce this data along with all the data wrangling steps. Therefore, you can see like what is in the data, how the data was prepared or transformed, and then you can customize if you like. Okay, so these are the things I have covered, and that's it for today, and that's it for this series. So we cover the why Excel users love Exploratory. I presented the 9 reasons, and I think the key thing is a couple things. Number one is that Simple UI is actually very helpful. People tend to think Excel is a UI tool, but once you start getting in, there are a lot of like more like a function-driven tool that happen to be in the UI tool. But Exploratory gives you the not just UI dialogue, but also the visualization. So you can depend on your intuition or eyes to do all sorts of different works. And second, the analytics is something that you want to use, you want to explore, and it's a powerful tool, and you can actually do it in a very easy and a quick way. And number three is the reproducibility. I think this reproducibility is hard to explain unless you have that problem. But once you start doing any data work, you hit this problem. And this becomes a bottleneck when you want to scale your organization or team in terms of like utilizing that data. So reproducibility is a really key thing. And so, these are things alone, this can be a single thing alone that you want to take advantage of what Exploratory can do or can help. Okay, so that's it for today. And then the next seminar is online seminar number 39. I'd like to introduce the parameter in the Exploratory. And you can parameterize a SQL query. You can parameterize filter in a data wrangling step or chart filter, or you can parameterize a calculation to make more like interactively simulate certain analysis. Okay, so that's going to be the same time, like 11 a.m. US Pacific time, 2 p.m. Eastern time, and next Wednesday. Okay, and then you can check out the detail from the LAM and online seminar menu, and then on the same page you can see the past recordings as well. Okay.